Hello everyone. So we ended up with this activity now. So we now proceed with our next topic, still on numerical integration now. So this time we'll talk about Simpson's rule now. So consider the graph below. So as you notice, we have this approximating function and the actual function. So this is the actual function, okay, and this is the approximating function. All right. So the graph of the approximating function, which is a parabola, okay? So this is the parabola with this equation, okay? Y equals to f of x at points intersects the graph of the actual function y equals f of x at points x sub 0, f sub 0, x sub 1, f sub 1, x sub 2, f sub 2. No? So the area below the graph of the actual function, okay, is approximated, no? The area below the graph of the actual function is approximated by the area below the graph of the approximating quadratic function. Okay? So in other words, if this is the actual function, and as you notice, the 3 points, so a parabola passes through the 3 points, okay? And the area now below that approximating function, which is the parabola, okay, is now the area that we will consider for the area below the graph of the actual function. Okay, so it is approximated by the area below the graph of the approximating quadratic function. No? So the area below the graph of this actual function. Alright? So the blue curve. So the area below the approximating function can be obtained by the formula. No? So this is Simpson's rule formula. So the area is equals to the integral of f of x dx, okay, limits from x sub 0 to x sub 2. So in this case, we should have 3 points. No? We should have 3 points. So we have x sub 0, f sub 0, x sub 1, f sub 1, x sub 2, f sub 2. Okay? And that is approximated using Simpson's rule formula. That is 1/3 h f sub 0 plus 4 f sub 1 plus f sub 2. So that is the formula. Okay? So 1/3 h. Okay? So 1/3 of this value. Okay? So this interval h, which is the same as the interval between x sub 1 and x sub 2. Okay? So 1/3 h of f sub 0 plus 4 f sub 1 plus f sub 2. Alright. So, okay. So h is the interval. The interval value h can be obtained by subtracting x sub 0 from x sub 1, or we subtract x sub 1 from x sub 2. Now, considering the graph below, applying Simpson's rule. In approximating the area below the graph of the actual function, considering more than 3 points on the curve. So, in this case, we consider more than 3 points on the curve. We have x sub 0, f sub 0, x sub 1, f sub 1. Okay. Then x sub 2, f sub 2, x sub 3, f sub 3, x sub 4, f sub 4. So given the 5 points, no, we're gonna use Simpson's rule in approximating the area below the graph of the actual function. Okay? So in that case, the total approximated area of the actual function by Simpson's rule, no, is given by this formula. Okay, so this formula is equal to 1/3 h of f sub 0 plus 4f sub 1 plus 2f sub 2 plus 4f sub 3 and so forth. So it has a pattern, okay? So until we reach f sub n, okay? So that's the pattern, okay? So let's go back. All right, so we have here 4 regions to consider: area 1, area 2, area 3, and area 4 in this example. Okay, adding all the four areas corresponds to the Simpson's formula, no? Simpson's rule formula. Okay, that will approximate the area below the graph of the actual function. Okay, so as you notice here, this is the actual function. Okay, and we consider the first 3 points, point 0, point 1, and point 2. Considering the 3 points, this is now the approximated graph, no? Sorry, okay. So this is now the approximated graph. Okay, the red one, the red uh, graph, no? Okay, so this red curve. Okay, so another approximation, okay, is this one. Okay, so this is, we consider again 3 points: first, second, and third. So this blue curve, okay, is another approximation of the graph of the actual function. So we consider the first approximation. Okay, we consider the graph below the, sorry, we consider the area below it. Okay, then another approximation. So the blue curve below it, there's also an area. So we add the two areas below this first approximation and below this second approximation. Okay, resulting to Simpson's rule formula. Okay, so we can able to determine the total area now using Simpson's rule formula. Okay, so in this case, okay, we have age, the interval age is calculated as x sub I plus 1 minus x sub I. Okay, so in our example, we have 5 points and we have f sub 0, f sub 1, f sub 2, f sub 3, f sub 4. Let us take a look at our previous example. Here we have f sub 0, f sub 1, f sub 2, f sub 3, f sub 4. Okay, so with that, okay, the formula now using Simpson's rule is now equal to 1/3 h of f sub 0 plus 4 f sub 1 plus 2 f sub 2 plus 4 f sub 3 plus 2 f sub 4. So this is now the formula considering for 5 points. Considering 5 points, okay, 5 values of f, we have this formula. Okay, we have the Simpson's rule formula. All right, so we now proceed. So let's see if this is right. N should be 4, so this is 4. N minus 1, so this is 3. N minus 2, so this is 2. So it's correct. Okay, then we have 2, 4, 1. So 2, 4, sorry. This should be f sub 4. Sorry. This should be f sub 4. It should end with 1 f sub 4. Okay, it should end with 1 f sub 4. Okay, so 1/3 age f sub 0. So it's 142 until we reach 241. So this is 241. Okay, it's correct. Okay, so that's the pattern. 142, 42, 42, 42. Okay, but it has a limitation. No? It should be fn minus 1 plus f sub n. Okay, so this is now the formula. No? So 142, 41. 142, then you will end up with 241. Okay, all right, so we proceed. So also h is equals to x sub n minus x sub 0 all over n. So this interval h, no? So this is the formula for interval h. And n is an even number. N should be an even number. Okay? So in our example, we have f sub 0, f sub 1, f sub 2, f sub 3, f sub 4. So this is the n value, which is 4. Okay? Which is an even number. So here's the problem, similar to the previous example in the past. No? Find the approximate value of the integral of square root of 1 plus x cubed dx, limits from 0 to 2. Taking n equals to 4 equals using Simpson's rule. Okay, so we have x sub 0 and x sub n, 0 and 2, n is 4. We have the value of the function. So this is f of x, okay, 1 plus x, square root of 1 plus x cubed. We substitute x sub I, so f of x sub I, f sub I, square root of 1 plus x sub I cubed, no? So we have hi, x sub I, f sub I, and then we have, so in this case, we consider n equals to 4. So this should be, this will be 0, 1, 2, 3, and 4. Okay? And then we have the first point is 0. So the first point is 0. So of course we have to determine the value of h, no? How do we determine the value of h? That is x sub n minus x sub 0 all over n. Okay? So the value of h is the interval h, x sub n is 2, x sub 0 is 0, n is what? N is 4. So 2 over 4, 0 0.5. That's why we have 0 0.5. Okay? So we have now x sub, we start with 0. So that is 0, 0 plus 0 0.5, 0 0.5. Okay? Then we add again, we have 1, we add again, we have 1.5, we add again, we have 2. Then we substitute 1 plus 0 cube, that is 1. Okay? 1 plus 0 0.5 cube, that is, then we take the square root, 1.0607. Then we have 1 here. 1 plus 1 cube, then we take the square root. We have 1.4142 and so forth. Okay? Then this is now the Simpson's rule formula. So for n equals to 4, this is the formula for Simpson's rule. 14241. Okay. So 1/3 each. So we have 1/3 of 0.5. Then we substitute the other values. We'll get this answer, 3.2397. Okay? Alright, so we proceed. So find by Simpson's rule the area under the curve determined by the given data. Number 2. So obtaining the estimated graph of the function upon plotting the points. So this is the estimated graph of the function. So we have, so given the points, no, we have 2, 4.16. So we have this. Then we have 5, 3.98. We have 8, 3.31. 11, 2.86, and so forth. Now, what will be the area under the curve determined by this, by the given data? No? So what is this area? The green area. No? So that is our concern. So this is just an estimation of the graph. No? This is just an estimated area. Okay? Because we don't know the equation of this curve. We don't know the equation of this curve. Okay? So we're gonna use Simpson's rule to estimate the graph of the function. No? Sorry, we're gonna use this. Uh, we're gonna use Simpson's rule to estimate the area below the graph of the actual function. No? Okay, so we proceed. So by Simpson's rule, so this is the area. So we have f of x dx from x sub 0 to x sub n approximately as, so equals to 1/3 h. So as you notice, I use uppercase letters. No, this is x and this is y. Actually, this is f. Okay, so this is f sub 0, f sub 1, and so forth, and this is f sub n. Okay. So this is, we have 6. So this is f sub 6. We have 6 points. No, no, no. Yes, yes. 1, 2, 3, 4, 5, 6. This is 0, f sub 0 to f sub 6. Yes. F sub 1, 3, 4, 5, 6. Okay. So this is the formula. No? So this is f sub 0, f sub 1, f sub 2, and so forth. Okay. So given 7 data points, n plus 1 equals 7. Okay. So thus n equals to 6. Okay. So the tabular interval value is this is 3. Okay. The tabular interval value is 3. So let us check. So 5 minus 2 is 3. 8 minus 5 is 3. 11 minus 8 is 3. And so forth. So we have 20 minus 2. X sub n minus x sub 0 all over n. N is equals to 6. 18 over 6 is 3. Okay? So that's it. So thus, this is the area now. So we consider up to 6. So we have 1, 4, 2, 4, 2, 4, 1. Okay, so that's the pattern. Okay? And then we'll arrive with this answer, 62.96 square units. This is the approximated area. Okay? So which is 62.96 square units. Alright, so we proceed. So this is the activity that you will do. Simulate the solution of the given problem using MS Excel such that when the lower limit and or higher limit excuse me, of the integral are changed, a new correct value of such integral will be obtained. Okay? Okay, I'll just change this to higher limit na lang. Okay? Such that when the higher limit, okay, of the integral is changed, no? Yan, a new correct value of excuse me, of such integral will be obtained, no? So when 2 is changed, no? So, so when the higher limit of the integral is changed higher than 2, okay? Greater than 2. A new correct value of such integral will be obtained. Okay, so that's it. I hope you get it, no? So this is just similar to lab activity 15. For lab activity 15, we use trapezoidal rule. For lab activity 16, we will use Simpson's rule. Okay, that's all for today. Good day, everyone.